Hello everyone, today I'm going to be teaching you an advanced edge pairing method for the 5x5 and up called Free Slice. This is a very easy method to move up to from the beginner's method, edge pairing you could call it. It's the same principles. You're basically just, when you slice to pair an edge, you're not going to slice back. And that's pretty much the only new thing, but there are a couple concepts that you just use your brain to solve. No new algorithms or anything. So first you want to try to find a pair of two edges. So I see two here. Here's one. Doesn't matter, they just have to be in the same orientation. So I'm going to use these black and blue ones, and then the other black and blues right here. So just line them up like normal and then pair them. Now here's where it gets a little different. You normally just uninsert with a mixed edge and just slice back, but instead we're going to look in the middle layers for preferably two other edges that are already matched up. So here I have orange and blue already matched up. So now we're going to look for the third orange and blue piece, and then we're going to take this edge out and replace it with that orange and blue edge simultaneously, so that we've already lined up our next pair. Now this is pretty intuitive, so you just have to make sure that you insert it the right way, flip the right way, so that you don't have to flip it later on. So here I want it to line up with this way or whatever, so just, it's pretty easy, just use your brain. So I just put that in while uninserting that solved edge, and now I can pair up that next edge, and then the cycle continues. So now I see the green red, so now I must find the other green red. Alright, let's see, there it is. So now we have to insert the right way. So this way would be wrong. As you can see, if I tried to pair it up, that wouldn't work. So I have to put it in the other way, and then I can pair it up. Now in a desperate case, you can take something like this and use the flipping algorithm, and I'm going to use this since I can push it out of the way with this piece. So this is sort of like solving the last two centers. So if I push this out of the way, I can flip it, push it back, and I can solve an edge that way also. So if I look around, and also here, if these two are mismatched, if I'm desperate enough, I can just insert the third one in, and I can tell that this one, if I flip, I can flip only this one, and then I can match them all up the right way. So if I did that, now I can match up that edge. So now I've got some better pairs. So I'm going to use the black-orange. So now here's the other black-orange. So I'm going to take my solved edge, uninsert it, and insert the other black-orange. So now there's not really anything that's matched up, but I do see the yellow-blue and this yellow-blue are oriented in the right way that I could match them up. So that's pretty much just as easy as two that are already paired up, just a little harder to see. So I'll just take the third one, replace my solved edge with it, and then pair up an edge. Now as we approach the last edges, with the last one you just uninsert it, you just insert it and replace the solved edge anyway, because you're just going to revert the centers back to normal and you're not really going to be matching anything up. So here these two are mismatched, so I'm just going to do the same thing, put the third one in, and then flip one of them. Alright, so I was desperate enough to do that. Now since this is the last one, I can just put it in that slot without having to worry about anything. And now I'll just revert my centers back to normal. And now we're to the last four centers. So this gets a little different. So you're going to sort of be solving this like you solve the last two centers usually. It's just slightly different. So you just want to find two that are matched up. It can be flipped or not flipped. I'm going to use flipped first as an example. So you want to find the other one. So here I'm using orange green. So here's the other orange green. And then orient it so that you can push it out of the way and form a properly formed block. Now you're going to push that edge out of the way to form a proper block. Then flip it and push it back so that will form your solved edge. Now I'm going to use the example of when you have a pair that is correctly oriented. So this red-blue, for example. Find the other one, but you don't want to orient it so that you can match it up. You want to orient it the other way, so that if you pushed it in, it would form the messed up way, you could say. So now what you're going to do is push this slot above this edge, flip the edge into the slot, and then push it back, which will solve the edge. So then we're going to push this slot above this edge, and then flip the edge into the slot, then push the edge back, which solves it. Now for the last two, I can't avoid parity here, and I'll show you a way in a little bit that you can avoid double parity or whatever. So I'm just gonna do this the normal way, just push it in, and then I have one parity that I have to do. Now, although it's preventable, if you do accidentally end up with this double parity case, there's a quick way to fix it. You can just use the flipping algorithm and one middle slice. So what we're just going to do is push the one flipped edge into the other flipped edge in the middle layer. And by flipping this edge and these two edges, it's going to make it, when we slice back, it will actually solve it. So I'll just flip, slice back, and then that gets rid of the double parity. Keep in mind that you can't avoid at least a single parity, but that's a quick trick so you don't have to do that really long algorithm twice. So that's advanced edge pairing for the 5x5. Thank you for watching.